Hi everybody, this is Mr. Folly, and welcome to podcast 6.4, where we're going to learn that molarity is the concentration of a solution, which means how much stuff is inside of it for its size. And we use molarity and stoich, so we're going to go through moles even more. Let's hop into that. Molarity is moles of solute over liters of solution. That's the formula. So solute is the smaller part, it's the solid for us, so salt in salt water. Solvent is the largest part, which would be the water in salt water for us, and the solution is both the solute and the solvent. So molarity is the moles of solute over the liters of solution, so that means both parts. Okay. Given 0.76 moles of NaCl in 250 milliliters solution, find the molarity. Well, molarity equals moles of solute over liters of solution, but I see a problem here. 250 milliliters, I need to know how to make that into liters. Well, we've done these conversion things before, but we're going to memorize this one. Milliliters, you just move the decimal point 3 spots over. 1, 2, 3. So 250 milliliters equals 0.25 liters. Okay, so it's going to be a 3 decimal point swing. So 0.76 over 0.25, and that's going to be 3 point something. So 0.76 divided by 0.25 is 3.04, and then the unit for this is called a molar. You do a capital M, it's a molar, like your tooth or your teeth. Some of you have more than one. 25 grams of KNO3 are added to 175 milliliters of solution. What is the molarity? Remember, molarity equals moles of solute over liters of solution. Well, I already know that's going to turn into 0.175 liters. Right, we learned that last slide. 25 grams, though, I need to turn that into moles. So, let's hop back here. 25 grams of KNO3 times dividing bar. I hate 2 grams of KNO3. Now, I only want to go into moles of KNO3, so this is a one-stepper. Right? I'm in the unit I want, so I'm finished. So, little g stands for grams, and little g stands for go to the periodic table. Potassium is 39.10. Plus nitrogen 14.01 plus 48 for 3 oxygens, and it's 101.11. 25 divided by 101.11, and it's 0.247 moles. So here we go. We got to plug them in now. 0.247 moles over, here's my volume, 0.175 liters equals. So answer divided by 0.175, and I get 1.41 molar. Easy peasy. How many grams of KCl must be added to 100 milliliters to make a 2.5 molar solution? Guess what I'm going to write? Molarity equals moles of solute, I've heard this before, over liters of solution. I hope you know that. Now I don't have moles, but I have 2.5. And I don't have, I'm going to solve for moles, I have 0.100 liters. So my moles are going to be 2.5 times 0.1, which is 0.25 moles of KCl. Now the question asks for grams, so now I need to make that conversion. 0.25 moles, get out of moles, and go into grams. 1 mole is go to the periodic table. Potassium is 39.10, I hope. Yep. Plus 35.45, 74.55. So 0.25 times 74.55 is 18.6 grams. Hey, this isn't bad. If the volume of a 1.55 molar solution is 125 milliliters, how many moles are in the solution? Hey, molarity equals moles of solute over liters of solution. I have 1.55, solving for moles, and I have 0.125 liters. To solve for this, I cross multiply. .55 times 0.125 is 0.194. Yeah. Ah! Not again. Uh-oh. Next one. Ooh, dare I erase it? As soon as I hit the eraser, it's going to go away. Oh, it's not going to erase. Get ready. Here it comes. So, here we go. Okay. 75 milliliters of 1 molar barium chloride react with 150 milliliters of 1.0 molar sodium sulfate. So, this part right here, if you're in prep, you get to skip that. But you do need to come. Oh, get back here. Ah, this is back. There you go. If you're in prep, you get to skip this one too. So I've got 2 of these problems to do. Okay, so I'm going to do A and B first, then I'm going to go back to C and D. So the first thing I have to do is write the reaction for this. So I've got silver nitrate, AgNO3, plus potassium chloride, KCl, and that's going to make AgCl. It's a double replacement reaction, right? Ag. K are going to switch places, and KNO3. Okay. This is balanced the way it's written. Find my limiting reactant. So what I'm going to do is always go through moles, right? So I'll always go through moles. So I'm going to find the moles of each of these guys to start with. Okay. So I know you've heard me say molarity equals moles over liters, but you're going to see moles equals molarity times liters. Okay, so I'm going to do that to start with. So to find my limiting reactant, I'm going to start with MV. So molarity, come on, is 1.5 moles times my liters, which is 0.2, equals 0.3 of AgNO3. And then for the other one, I have 0.15, whoops, I did that backwards. I have 1.8 moles, molar, MV, and my volume is 0.15. See how I solve molarity equals moles over liters? So moles equals molarity times liters. And I had to switch it to the right thing. 1.8 times 0.15 is 0.27. And that's moles of KCl. Now I'm going to convert both of those into AgCl. Into AgCl. Oh, you're kidding me? Those numbers are gone. Okay. So I do remember, hopefully you wrote it down, 0.3 moles of AgNO3 times dividing bar, moles of AgNO3, moles of AgCl. That's 1 over 1 times dividing bar, 1 mole AgCl. And, not moles, grams of AgCl. Now this was 1 over 1 because my coefficients are 1 all the way through. Silver, go to the periodic table, is 107.87 plus chloride, 35 plus 45 is 143.32. So then I have 0.3 times 143.32 is 42.996 grams AgCl. And the other one was 0.27 of KCl. 1 mole KCl and 1 mole of AgCl. I'm converting that into 143.32 grams as well. And 1 mole. So let's see if I can get this to come back. Probably can't. This is 0.3 moles. Oh, that's 0.3 moles. Oh, come back here now. This was 0.3, 0.27 moles, isn't it? 0.27 moles of KCl. And then 1 mole KCl. So 0.27 times 1 divided by 1 times 143.32. And that equals 38.69. Now if I can find out what my answer was before that. Oh, the other one was 42, right? So these are both grams of AgCl. So the smaller one is this. So find the one that makes the least amount. The mass of AgCl actually produced is 38.69 grams, how much is actually produced. And that came from, this came from KCl. So that is my limiting reactant. Okay. We're going to skip C and D because my computer's acting like a weirdo. Okay. Oh, look at those answers. Isn't that clever? Okay, so we're going to do just A and B. Whoops. Just do just A and B for this again. So 75 milliliters of barium chloride. So remember, moles equals MV, or ML, right? So for this first part, so barium chloride, so BaCl2 equals MV equals, I'm going to put little moles here. The molarity of barium, come back here. Molarity of barium is 1. Volume of barium is 0.075. See, I had to slide that 3 spots. 1, 2, 3, 0.075. And that equals 0.075 moles of BaCl2. And then sodium sulfate, Na2SO4, is going to equal molarity 1.1 times volume 0.15. 1.1 times 0.15. 1.1 times 0.15 is 0.165. Okay. Now I'm going to convert both of them to figure out the mass of barium sulfate that forms. But I need to write the reaction first. BaCl2 plus sodium sulfate, Na2SO4, is going to give me BaSO4 plus NaCl. To balance this, I have 2 NAs and 2 Cl, so I'm going to put a 2 here, and that's it. I'm balanced. Okay. So, oh, the bell rings, and my screen is killed. So I'll tell you what, we're going to have to finish these bad boys in class, and I'm just going to have to say, just like the things I wrote down, toodles. Come on, come on.